So, good morning. Hello students. Yesterday I talked about Rodrigues formula. We derived the Rodrigues formula of a Hermite polynomial. Okay. So today we'll see the recurrence. Today we'll see the h naught of x means h naught of x, h1 of x, and h2 of x. The values of h naught of x, h1 of x, and values of h2 of x. How to get from the Rodrigues formula. Then we'll see the recurrence relation. Then the Hermite polynomial chapter will be closed. Okay. So let's see. This is the Rodrigues formula. So yesterday we derived it. So let's find out the value of let's find out the value of h naught of x. So put n is equal to 0. Put n is equal to 0. Then so minus 1 power 0 e power x square d power 0 by dx power 0 e power of minus x square. Okay, which is equal to 1 into e power of x square. This is x square. Okay, this is x square into, so this is the zeroth derivative. So zeroth derivative of anything will be e power of minus x square, which is e power of x square minus e power of x square, which is equal to 1. So therefore h naught of x value will be 1. Okay, so let's find out the value of h1 of x. Okay, so h1 of x, so keep the 1 in the Rodrigues formula. Okay, so minus 1 whole power 1 e power x square d power 1 by dx power 1 e power of minus x square. Okay, so now we have to do the first derivative of e power of minus x square. So minus 1 e power of x square. So first derivative will be minus 2x into e power of minus x square. Okay, so minus minus plus, then you get 2x into e power of x square into e power of minus x square will be 1, which is equal to 2x. Therefore h1 of x is equal to 2x. Okay, then you can, like this you can find, then like this you can find uh, the values of h1 of x, h0 of x, h2 of x, h3 of x, like that. So by the Rodrigues formula. So put n is equal to 2. Okay, put n is equal to 2. Then in Rodrigues formula, keep n is equal to 2. So square e power of x square d square by dx square e power of minus x square. Okay, so which is equal to 1 into e power of x square. So first derivative will be minus 2x into e power of minus x square. Okay, so minus 2 will come outside, and the first derivative will be e power of minus x square plus minus 2x square e power of minus x square. Okay, so take it out, e power of minus x square outside, then you will get 4x square minus 2. Okay, this is the h2 of x. Okay, so let's solve one problem based on this what I taught now. Okay, so right right f of x is equal to x square plus 3x in terms of Hermite polynomial okay answer. So we found out h2 of x is equal to 4x square minus 2. So therefore x square is equal to 1 by 4th of h2 of x plus 2. Okay, so f of x is equal to 1 by 4th of h2 of x plus 2 plus 3 times of h1 of x. Okay, so this is the one quadratic equation with c is equal to 0 here. There is a constant. So we have converted this x square plus 3x. We have written the x square plus 3x in terms of Hermite polynomials. So finally we got the expression like this. Okay. So let's solve the recurrence relation. So let's solve the recurrence relation. Okay. The first recurrence relation is like this: 2 power n. Sorry, 2 times of n h1 h and h n minus 1 of x, which is equal to h prime of x. H prime means first derivative of hn of x. So second recurrence relation is 2x hn of x is equal to 2n hn minus of x plus hn plus 1 of x. Okay, so we have to prove the first recurrence relation. So we know the generating function of Hermite polynomial. So we know the generating function of Hermite polynomial, which is equal to e power of 2tx minus t square, which is equal to summation of n is equal to 0 to infinity. So t power n divided by n factorial hn of x. Okay. So first differentiate with respect to x. 2t, so derivative with respect to x of above equation, of above generating function. So 2t times, so e power of 2tx minus t square. So differentiate of e power x something will be e power x, e power of ax will be a times of e power of ax, right? So which is equal to summation of n is equal to 0 to infinity t power n divided by n factorial. One second, wait a second. So t power n h prime of x. Okay. So compare the coefficients of t power n. Okay. So compare the coefficients of t power n. Sorry, I forgot to write one thing. So 2t times of summation. So e power x, you can write it as so e power of 2tx minus t square will be a generating function, so which is n is equal to 0 to infinity. So t power n divided by n factorial hn of x, so which is equal to summation of n is equal to 0 to infinity t power n divided by n factorial h prime of x. Okay, this is the, see, the in the bracket you have the e power of 2tx minus t square, right? So which is equal to a generating function, which is summation n is equal to 0 to infinity t power n divided by n factorial hn of x, which is this thing, which is equal to the above expression. So now compare the coefficients of t power of n. If you compare the coefficients of t power n, so now so if you expand this thing, if you expand the above expression, so 2t, so if you bring t into t plus 1, so summation n is equal to 0 to infinity t power n plus 1 divided by n factorial into n hn of x, which is equal to summation of n is equal to 0 to infinity e power n n factorial h prime of x, right? So if you expand this summation, what you get? 2 times of if you get the expansion, then t into h naught of x of t square by 2 factorial 1 factorial h1 of x up to so on, plus, so we want the t power n coefficient. So at n minus 1, n minus 1th term, we will get, okay, t power n n minus 1 factorial h n minus 1 of x up to so on, then you get this uh, summation, right? Then compare this t power n with respect to compare left hand side the t power n coefficients. Okay, So did you get what I said? So the t into t power n, which is equal to t power n plus 1. Okay, then put n is equal to 0, then which is equal to t power 1 into h naught of x by 0 factorial, which is equal to 1. Okay, so next the put n is equal to 1, then you get the t square by 1 factorial, which is into uh, h1 of x. Okay, plus up to so on. So if you want to get the t power n, you will get at n minus 1 term, right? So t power n divided by n minus 1 factorial h1 of 1 of x. Okay, so as it is, which is equal to right hand side term. Okay, then compare these two terms, then 2 times of h minus 1 of x divided by n minus 1 factorial, which is equal to h prime of x divided by n factorial. Then 2 times of h prime of x minus n minus 1 factorial, which is equal to h hn prime of x divided by n into n minus 1 factorial. So n minus 1 factorial, n minus 1 factorial will cancel out. So you will get h prime of x, which is equal to 2n hn minus 1 of x. Okay, so you got the first recurrence relation, okay, of Hermite polynomials. So let's find out the second recurrence relation. Let's find out the second recurrence relation. Okay, let's find out the second recurrence relation. Generating function of Hermite polynomials. Let's rewrite that generating function, e power of 2tx minus t square, which is equal to summation of n is equal to 0 to infinity t power n divided by n factorial hn of x. Okay, now differentiate with respect to t. Then what you get? If you derivative with respect to t, then you get 2x minus 2t times of e power of 2tx minus t square, which is equal to summation of n is equal to 0 to infinity n into then which is equal to n into t power n minus 1 divided by n factorial hn of x. Okay, so again e power of 2tx minus t square, which is equal to a generating function 2x minus 2t summation of n is equal to 0 to infinity t power n by divided by n factorial hn of x, which is equal to summation of n is equal to 0 to infinity n into t power of n minus 1 by n factorial hn of x. So compare coefficient of t power of n. 2x. See the what you do is so multiply the summation with with this bracket. What are the terms there in this bracket? So 2x into summation of this whole term, okay, then minus this summation of the whole term. So before you're going to compare this, let me write the few more steps, then you can easily understand. So 2x into summation of n is equal to 0 to infinity. So t power n divided by n factorial hn of x minus 2t summation of n is equal to 0 to infinity t power n plus 1, let okay, by n factorial hn of x, which is equal to summation of n is equal to 0 to infinity n into t power of n minus 1 n factorial hn of x. Okay, then so you will get, so now compare the coefficients of t power of n. Okay, now compare the coefficients of t power of n. So 2x, okay, 2x times of hn of x divided by n factorial minus 2 times of hn minus 1 of x by n minus 1 factorial, which is equal to n plus 1 times of hn of x divided by n plus 1 factorial. So how did I write that expression? Because of this summation. So I wrote the 2x times of hn of x divided by n factorial, right? This first equation. Okay, so this first equation C. Okay, next, so when, so we want the t power nth coefficient, right? So when will I get, so h, if you put n is equal to, if you put n is equal to n minus 1, then you will get t power nth coefficient, right? Then the 2 times of hn minus 1 of x, hn minus of x by n minus 1 factorial. So you have n minus 1 factorial. So when do you get the t power n? So when put n is equal to n plus 1, so then you get t power nth coefficient. Then you get n plus 1 into hn of x divided by n plus 1 factorial. Okay, so this is the way I wrote the expression. In this way I wrote the expression. So if you solve this equation, you will so you have the 2x times of c, this is the n plus 1 factorial, right? So you can write n plus 1 into n factorial, right? So into n minus 1 factorial, you can write, so 2x into hn of x divided by n into n minus 1 factorial minus 2 hn of x h minus 1 of x divided by n minus 1 factorial okay, n plus 1 n plus 1 into hn plus 1, sorry, hn plus 1 of x, here hn plus 1, okay, hn plus 1 of x. Okay, so then here n into n plus 1 into n minus 1 factorial. So n minus 1 factorial, n minus 1 factorial, n minus 1 factorial will cancel out. Okay, here n plus 1, n plus 1 will cancel out. So you end up with 2x into hn of x divided by n minus 2 times of hn minus 1 of x, which is equal to hn n plus 1 of x divided by n. Okay, So now if you rearrange this, then you get 2x hn of x minus 2n hn minus of x, which is equal to hn plus 1 of x. Okay, this is the uh, expression of second recurrence relation of Hermite polynomial. Okay, thank you. I hope you understand the Hermite polynomials. The Hermite polynomials concept is completely finished. So if you have any doubts, you can ask me in WhatsApp. Okay, or write a whatever you have a doubt, write on the piece of paper and send it to me in WhatsApp. Okay, so we finished Hermite polynomials. So we'll meet in the next class with a logarithmic polynomial, right? Okay, bye. Thank you.